In this lesson, we're going to continue to explore percents and the language of percents. We're going to look at it kind of with this shopping problem or paying money for objects. Let's say you go to the store and you see an item and it's marked with the original price. The price of the item would be considered the whole or 100%. It's really important to keep in mind that the whole is always 100% in these problems. Because then if you're given a discount, let's say you're given a discount of 20%, you're always given two pieces of information. When you read a problem and it says that there's a discount of 20%, you should always be thinking about that relationship. If there's a discount of 20%, what percent are you paying? Well, the whole thing is 100%. So we know that the percent of discount plus the percent that you're paying should total up to that whole thing. Because if the value is 100% of the whole and you're discounting at 20%, it's like you're taking off 20%. That means you're paying 80%. And both of these are parts. So they should add up to the whole value. 20% plus 80% equals 100%. This is going to be very useful when you encounter types of problems that say, some boy went to a store, he went to go buy a bottle of toothpaste that was $10. There was a discount of 20%. How much did he pay? So instead of having how much money did he pay, instead of going and then doing subtraction, you could go straight to this percent paid to solve these types of problems. This is also going to start corresponding to amounts of money. So we know, let's say in that example, the whole object was $10. If you have a 20% discount, that would then correspond to a dollar value, or $2, and the amount paid would be $8. Getting back to this language of percents, what does 20% really mean? It's going to be useful to start thinking about with harder problems. That 20% means 20 out of 100. So that means for every $100 you spent, you would get $20 off. What does 80% mean? That for every $100 that you spend, you would have to pay 80 of those. So keep that in mind as you're solving these types of problems. We're going to use this for a couple examples on this next page. On these, you're given a couple pieces of information. You're given an item, an original price of the item may or may not be shown in the table, the sale price, the amount of discount, the percent saved, and the percent paid. Given two pieces of information, you should be able to figure out all of the rest. So let's say you have a phone and the sale price is $120. That means that's how much you're paying for the phone after the sale. The sale price is $120 and you saved 20%. Well, let's go straight and figure out the next part of this. If you save 20%, that's just like this last problem you did, then you pay 80%. Now you can figure out that relationship. Okay, you're paying $120, that's 80%. So when you set up your tables, you paid 80%, and that corresponded to $120. Now you can use this to find out what would 100% be. Let's just go down to 10 by dividing by 8, and 120 divided by 8 is 15. So now 100% would be 150. So the original price must have been $150. Of that $150, you got a discount of 20%. So we know then the whole thing was $150. And you could have just figured that out using this too. It will be $30. Or you can just go, 10% would be 15 and 20% would be 30. And because both tables, the whole is the same value, you could have continued it with your first table as well. So the amount of discount was $30. Of course, you could have just looked at your table, and so if the original price is $150 and the sale price is $120, then you got a $30 discount. You don't need to even go back and use percentages. I'm going to just erase this and look at this next problem. In the next problem, museum tickets cost $70 for the original price. Because you bought the family pack, let's say, you were able to get an amount of discount of $24.50. So let's take a look at our two pieces of information given. We got $24.50 discount, so we can figure out the sale price by using subtraction. 6, 9, 10, 5. So you paid $45.50. So how do we find out what percent saved now and percent paid? Well, I'm going to use a table and look at if you saved 100%, you would have gotten in for free, and you would have saved $70 if you saved 100%. Well, you didn't save that. You saved, or you still had to spend $45.50. So what you're thinking is $45.50. Actually, I'm finding out percent paid right now because this is my paid. I paid $45.50. So we're finding what percentage I paid. If I wanted to find what percentage I saved, I could go to $24.50 over here. So I need to think to go from 70 to 45.50, what do I need to divide by? I could also go from, to make this problem simpler, I could stop off at 7 and 10 by dividing each side by 10. And now I could think, what do I have to multiply by, which is a little bit simpler to think about. So you can do 45.50 divided by 7, and you need to multiply by 6.5. So you need to multiply 10 by 6.5, and that's 65. So $45.50 corresponds to how much you paid, the amount of money you paid. So that corresponds to right here, which is 65%. So you paid 65%, which means you saved 35%. Again, you have to keep in mind which parts of your table are corresponding to each other. 45.50 is the price you paid, so that's 65%. So if I use your table to go to 24.50, that would be the amount saved. For this last type of problem, the shoes, you had a discount of $20. You paid 80%. That means you saved 20%. Think about what corresponds. Well, the discount, that dollar value corresponds to how much you saved. So we're given our piece of information to put in our table. 20% corresponds to $20 because you saved 20% and you saved $20. So that's the relationship. So 100%, let's multiply by 5, and we're obviously going to get the same thing, is 100. So that total price, the original price, must be $100. And we know, I'm not going to go back in my table, if you got a discount of $20, that means you paid $80 or 80%. So that's the type of strategies, thinking about always two pieces of information that you're given. When you finish, we can also start working on some word problems using Math Playground to practice these types of strategies with word problems.